Hey there, it's Joe. So one thing you should know about me is that I like to experiment, push the limits, and see what's possible. In that spirit, I wanted to push this lathe to the maximum to see how heavy of a depth of cut and feed rate I can take while roughing steel. To do this, I needed to get a tool that I know can handle more than this lathe can handle. So I got a CNMG holder that takes a 644 insert, which is a 3/4 inch IC. Now, to give you a comparison, typical holders used on a lathe like this is a 432 CNMG, which is a 1/2 inch IC. Now take a look at the difference on that. This is a beefy ass cutter. I'm going to start out with an 1/8 inch depth of cut and 15 thousandths per rev feed rate, and then I'm going to increase the depth of cut and feed rate from there until the lathe stalls out. So we'll see what happens. So this is a good baseline for cutting steel on this lathe, and that looks like it's cutting really nice, breaking a nice chip. Here we go at 3/16 of an inch depth of cut, and that's doing really great. I like the look of that. Here we go, 1/4 inch depth of cut. Oh! And it stalled out. So that was too heavy of a cut for this lathe. Back to our 1/8 inch depth of cut. We're trying a higher feed rate at 20 thousandths inch per revolution. And that looks great. Look at those. Look at those chips. Alright, now we're just increasing the feed rate to 25 thousandths per revolution. Oh yeah, look at that. That looks great. Here we go, 30 thousandths per revolution. Thing's flying. Alright, now this is going to be the maximum feed rate recommended by the tool manufacturer at 35 thousandths per revolution. And that looks great. Alright. Now let's try 3/16 depth of cut at 20 thousandths per revolution. And it's doing it. Oh yeah. So let's try a 3/16 depth of cut at 25 thousandths per revolution. Oh yeah. That's moving some material. Alright, 3/16 depth of cut at 30 thou per revolution. Oh! And it stalled out. So that's too heavy for this lathe. Now that was fun. So we found out that the maximum depth of cut that I can do is 3/16 of an inch in radius or 3/8 of an inch in diameter at a feed rate of 25 thousandths per revolution. I tried a 1/4 inch depth of cut or a 1/2 inch in diameter, and that broke the insert. I tried feeding it at 3/16 of an inch depth of cut or 3/8 in diameter at 30 thousandths per revolution, and that broke the insert. And then I tried raising the surface footage from 500 to 750, and that broke the insert. Now it's important to point out that the reason that the insert was breaking is because on my lathe I've got the motor and then I've got the spindle, and they're connected by belts. Okay? Now what happened was at those points in time where the insert was breaking, there was more torque on the spindle than the belts could handle. So my motor was still spinning, but it was slipping on the belts. and the spindle stopped. Once the spindle stopped, then the tool kept feeding, and that broke the insert. So on a lathe with more horsepower and stronger belts, this tool could handle a heavier cut than I can handle on my lathe with my setup. But I'm still fairly impressed with what this lathe was able to do. And on a regular basis, I would never push it this hard. Because I want to run that insert consistently and know that it's going to last a certain amount of time and that it's going to gradually wear out rather than suddenly break and possibly damage a part that I'm making. And I hope you guys enjoyed this video, and take it easy.